Okay, the next topic in the course is going to be how do you solve systems of equations when you don't want to graph them. Graphing takes up a lot of paper, a lot of time, etc. There's mathematical ways to do these things that are much more powerful than graphing. I mean, we've seen in a couple of examples that I've done on the board that you've got to be very precise with exactly how you draw the lines, or some of the points don't look exactly right. Of course, that can be helped by using graph paper and a straight edge, but it's pretty tedious, especially when the lines are kind of complicated, okay? So I'm going to show you a technique that's very powerful, very common, and it's very much mandatory for you to understand for Algebra 2. It's called solving a system of equations by substitution. This is actually my favorite method. I use this one all the time. Let me show you how to do that with an example. Okay? Let's say you have a system of equations like this. Y is equal to 2x, and the second line is x plus y is equal to 6, and I want to solve this system of equations. Well, what I'm going to do is, remember these two things, whenever these two lines are satisfied, there's one point that's an intersection of these two lines. What I'm going to do is I'm going to take the first equation, which says y is equal to 2x, and I'm going to turn around and I'm going to plug it into that second equation. Okay, into this spot for y, and then I'm going to go from there, and you'll see where we go. So let's do that. Using the second equation, x plus y, but remember y is just equal to 2x, so I'm going to put a 2x here, equals 6. This is very crucial for you to understand what we're doing here. Okay, I've got two equations. I've got one of them already solved for y. I take this y, which is equal to 2x, I put it in here, and this is what I get, x plus y, but in this case y is equal to 2x equals 6. I can simplify this and say 3x equals 6. And then I can solve for x and say x is equal to 2, because I just divide both sides by 3. So I know that x is equal to 2. Now, I'm going to use a different color to make it clear. You can take what you have found here and plug it back in to either one of these equations, and they'll both give you the same answer. Okay? So let's go ahead and try to do that, and I'll just do it in a different color. I know that x is equal to 2. Let's say I put it up into this top equation. Y is equal to 2 times x. X is given by 2 here. We just found that. That's equal to 4. Let's say I put it into this bottom equation instead. Let's just say 2 goes into here. So I've got 2 plus y equals 6, if I happen to choose the second equation. Now I solve for y, and you'll see right away that y is equal to 4. So what I found is the solution. The solution is x is equal to 2, y is equal to 4. This is the solution to that system of equations. You take one of the equations, plug it into the other one, and solve for a variable, in this case x. Then you take what you found, you plug it back in to either one of these equations, and then you'll get the other variable that you're looking for, y. And what you've done here is you've proven that these two numbers, 2, 4, is a solution of this system, and of course if you were to plug these numbers back in, you would find that it is satisfied. There. I think the easiest way to kind of get your arms wrapped around this is just to keep on working. Let's say we have another system. Y is equal to 2x minus 6. Another equation is 2x plus y is equal to 6. This is my system. What I'm going to do is I'm going to take this equation and I'm going to plug it in here. The reason I'm going to do that is because this one is already solved for y. So half my work's already done for me. Okay. So what I'm going to get here is I'm going to have 2x plus y. But in this case, y is given by this stuff. So I'm just going to stick this stuff in here for y and say it's equal to 6. All I've done is I've taken this and I've put it where that is. Now this is something I can solve. 2x plus 2x is 4x. And I can say 4x minus 6 equals 6. And just keep on working. 4x. And I can move this 6 over here by adding it. It is equal to 12. Because I can add 6 to both sides. 6 plus 6 is 12. Of course, x in this case is going to be equal to 3 because I'm going to divide both sides by 4. 12 divided by 4 is 3. Okay. Now what I'm going to do next, this is half the answer. I'm going to take this answer, I'm going to plug it back in this equation. Y is equal to 2 times what I've just found here, which is x is equal to 3 minus 6. Okay, so then y is equal to 6 minus 6, y is equal to 0. So the answer here for the solution of this system of equations is 3, 0. So it starts to become mechanical after you do this. You plug one into the other, solve, take the answer, plug it back in, and so on. And that is why this solution technique is called substitution. It's called solving a system of equations by substitution. It's very powerful, and it always works. Okay? It's just sometimes it can be more mathematically difficult than others. Let's say I have r plus 3s equals 9. And 3r plus 2s is equal to 13. Now, I could have used x and y, or a and b, or c and d. In this case, I just use r and s just to show you that these letters don't really mean anything. Okay? Notice I don't have either one of these equations really solved for anything. I mean, they're both kind of written like this, and I need to have something solved for one of these variables to actually use it. So I'm going to take the top equation, I'm going to solve for r. r is simply, I'm going to move 3s over, negative 3s plus 9. I mean, you can see that. You just move the 3s over by subtracting it. It cancels on this side, and you get the negative 3s over there. Okay, next thing I'm going to do is I'm going to take this r, and I'm going to put it right on into that equation. Okay, so 3 times r is this stuff right here, negative 3s plus 9, plus, I'm just going to write the rest of the problem down, nothing else changes. Okay? Now this starts to look a little bit more messy than the other problems, but let's just plow through it. Let's distribute this 3 in. 3 times negative 3 is negative 9s, okay? Plus 9 times 3 is 27, plus 2s, this stays the same, equals 13. Okay? I can combine my negative 9s with my 2s, and I'll get negative 7s. Okay? And I can just move this 27 over here by subtracting 27. I'll have negative 27 plus 13 on the other side. Okay? And what I'll be left with is negative 7s is equal to negative 14. If you take negative 27 plus 13, you'll get a negative 14. So then s is equal to, I'll just divide negative 7 on both sides, I'll get a positive 2. Now this looks pretty complicated, but it's very mechanical. You plug this equation into here, you get something kind of big, so you have to distribute your 3 in, you have to collect like terms here, collect like terms here, and then just divide and solve for s. Now, what we're going to do next is I'm going to take s, and I'm going to go back and I'm going to plug it back in up here. You could plug it into either equation. I'm just going to pick the top equation, okay? Because I just think it's going to be a little bit easier. R plus 3 times s, but I just found s is equal to 2, equals 9. R plus 6 is equal to 9. Subtract 6 from both sides, r is equal to 3. Okay? So then the solution to this problem is s is equal to 2, r is equal to 3. And this is just a point. If this were x and this were y, then you would write it as 2, 3. So you can see that even though the math got a little bit more detailed in that problem, I mean, it was really the same steps. Nothing really changed. You just mechanically take one of the equations, substitute it into the other one, solve for one of your variables, and then press. Let's say I have another system of equations. Okay, given by 7x minus 2y equals negative 1. Okay, and also the other equation is negative 5x plus 2y equals negative 1. Okay, What I need to do is plug one of these into the other. And before I can do that, I need to solve for one of these variables. So in this case, I'm going to go ahead and solve for y. Okay, so let's go ahead and do that. Negative 2y equals, I'm going to move the 7x over, negative 7x minus 1. Okay? Now, I want you to notice something. There's a 2y here. There's a 2y here. So I don't even need to really solve for y here. I could do that. I could solve for y and plug it in, but I could also just solve for 2y. 2y equals, divide by negative 1, 7x plus 1. Okay, I just divided by negative 1 here, so I solved for 2y. And I can take this and plug it into here. So let's do that. Negative 5x plus 2y. 2y is equal to this. 7x plus 1 equals negative 1. All I did was solve for 2y and plug it in there. Okay? I can simplify this. That's just going to be 2x, negative 5x plus 7x, plus 1 equals negative 1. 2x equals, pull my 1 over here, negative 2. Just subtract 1 from both sides. X is just equal to negative 1. Okay? And then I can take that and I can plug it really into anything I want in order to get the answer. And I'm going to go ahead and choose to plug it into this equation right here, because in the end, what I want to solve for is y. So let's do that. 2y, which is right here, is equal to 7x. X is negative 1, okay, plus 1. Okay? So then y is equal to minus 7 plus 1. So then y is equal to negative 6. Okay, but what I did is I forgot there was a 2y here. Okay, 2y is equal to negative 6 right here. So then y is equal to negative 6 divided by 2 is negative 3. Okay? So then the answer to this system of equations is just going to be x is equal to negative 1, y is equal to negative 3. I took the first equation, solved it for 2y, plugged 2y back into here, got an answer for x, took x, plugged it back into here, and then once I finally remembered to carry my 2y down, just plug that negative 1 in here, and you get 2y is equal to negative 6, y is equal to negative 3. That is the solution to the problem. So you can see that it's pretty methodical. You need to work carefully, consistently, but basically all you're going to end up doing in the end is taking one equation, solving for one of the variables, plugging it into the next equation, then you'll arrive at you'll solve for one of the variables there, and then you'll take that answer, plug it back into the top to get the other variable. And that's the general way in which you'll do it.